Good evening, dear students. This is Jayalakshmi of IK College of Engineering. Already we have started with that embedded system W8691. We have started with that introduction and we have studied that what are all the basic structures in that embedded system, and the design process we have completed. Now we are going to discuss about that structural units in embedded system and that process structure of an embedded system and selection of a processor in embedded system. These characteristics of embedded system already we have studied. Okay, let me start with the components of an embedded system hardware. See that one, this is the general structure for an embedded system. So for a hardware architecture, we are in need of a power supply and reset oscillator circuit, and then we are in need of input devices for interfacing input devices to the processor and the driver circuit needed to process that one. Then we are in need of the same as that input device drivers. Here also we are in need of output interfacing device drivers. And then inside that system application specific circuits, when you want to connect a embedded system with one particular application, we are in need of special application circuits for that one, that should be connected with this one. And then what type of processor we need, we have to include that one, the timers and then interrupt controller. Additionally what we need, that should be added with this. And then program memory and data memory, serial communication ports and parallel communication ports are needed. This is the general components of that embedded system hardware. Let me start with that one. First one, power source. When we are discussing about that power source, the system should own its own power supply with separate supply rails for the I/O devices, clocks and basic processor and memory and analog units. Supply from a system to which the embedded system interface, for example in a network card, charge pump concept used in a system of little power needs, for example in a mouse or contactless smart card. So when you are going for that power sources, what type of power rail you need, that is when you are using a washing machine, we need more power for running the motors, and for running the DC motors we need excess driver circuit for drive that motors. Also for driving that for power we are in need of power supply for the boards controlling that system. So we are in need of separate supply for different systems inside that embedded system. Okay, and power dissipation management, clever real programming by wait and stop instruction, clever instructions of reduction of the clock rate during specific set of instruction, optimizing the codes and clever enabling disabling of the use of codes that will reduce the power dissipation. So based on the requirement, you have to reduce the size of the program. You can reduce the clock signals needed for that one. Next one, memory. The memory of the system is responsible for holding the control algorithm and other important configuration details. Memory for implementing the code may be present on the processor, or it may be implemented as a separate chip, or it can be interfaced through some separate interfacer. Okay, in a controller based embedded system, the controller may contain the internal memory for storing the code. So we are having that one. When you are talking about the memory, we are having separate code for storing that code. We are having separate read only memory, and then for storing the data we are having random access memory, and we are having flash memory, which are whenever we need that we can store that frequently used data in the flash memory. Okay, these may be present inside the processor, that will be more useful. So you can choose a microcontroller when you are going for that embedded system. Then clock and I/O devices. Clock to keep the whole system synchronized. It may be generated internally or obtained from a separate crystal or external source, but modern MCUs offer a considerable choice of clocks. And then input output ports, already I told you, to communicate with the external world we are in need of that internal and input and output ports, that should coming with the drivers also. Common user interface input devices are keyboards, push buttons, switches, keypad, touchpad, like that one. Common user interface output devices are LED, LCD, buzzers, and then other control devices, alarms, like that one. Then timer and serial communication interface. Watchdog timer. Watchdog timer is an electronic timer used to detect and recover from computer malfunctions. The watchdog timer restarts the system on occurrence of a software problem if a selected time interval expires. For example, if you are having a very good example of this watchdog timer is your mobile display. If you are not using your mobile display for more than 1 second, that is, you have to prefer that one for 1 minute or 2 minutes. How much time you have chosen, that up to that one it will watch that whether you are doing any action. If you are not doing any action during that time period, it will switch off that display. Okay, that is an example for your watchdog timer. Similarly, here we are using that watchdog timer to go check whether that processor is continuing process or is there any malfunctions means it will restart that processor. Okay, then real-time clock. These are the needed in application that must track with the time today. Okay, day-to-day life we are using real-time clock. So whenever we are processing, for example, if you are using a washing machine, we have to set that time. Based on that time, we can plan our duties. Okay, so we have to interface with that. We have to interact with real world. For that one, we are in need of this real-time clock that shows the exact regular time with that consumers. Okay, serial communication interface. A wide choice of interfaces is available to exchange information with another ICs or system. They include ART, serial peripheral interfaces, inter-integrated circuits, universal serial buses, controller area network, Ethernet, and many other. These are all serial communication interfaces. Then ADC and DAC and interrupt controller. In our regular usage, we are using only analog signals. These signals cannot be processed by your processor. So we have to convert these analog signals into digital signals so that it can be processed by the computer. Similarly, when you want that output as an analog signal, that time we are in need of a digital to analog converter. And then interrupt controller. Whatever work we are doing, it will be sensed by a sensor, and based on the sensor output only the processor will do that. And for example, if you are doing that washing processor, once that water level is reached, based on the sensor output, if it reaches the water level, selected water level, the processor has to go for the next process. That is, after water level finish, it has to start the washing process. So in embedded system, we are in need of that interrupt controller for regular usage. Next, we are going for the structural units in a processor. This is about the structural units in a processor. I think you have already started with that. You have studied that 8085 microprocessor. It's just a recall of that one. We have already discussed that in that 8085 processor or 8086 processor or in 8051 microcontroller. So whenever we are going for that one in a processor, we are having that memory address register. It holds the address of the byte or word that should be fetched from the external memories. Processor issues the address of instruction or data to memory address register before it initiates fetch cycle. Then memory data register, it holds the byte or word fetched from external memory or IO address. Then we are having that system buses. We know that one in the general architecture of your microprocessor, we are having address bus, data bus, and control bus. Here also we are having that one internal buses to connect all the main internal devices, internal parts of the microprocessor with other parts. We are using this internal bus. Then we are having that address bus that holds the address of the data or address of the memory to be used. Then data bus, it carries an data to be carried out. Then control bus, it carries the control signal from control unit to other units. Then bus interface unit, an interface unit between the processor and internal units and the external buses. Then instruction register, it sequentially takes the instruction code. It holds the address that is opcode to be executed in that instruction register. Then instruction decoder, what is the opcode there in the instruction, that will be decoded by this instruction decoder. Based on the decoder instruction only, the control unit will deliver the commands to be process the data. Then application register set, a set of on-chip register used during the processing of instruction of an application program. A register window, a subset of register with each subset storing static values of software routine, or a register file associated to a unit such as ALU or FLPU. Then arithmetic logic unit. This unit processes all the arithmetic and logical operations. One of the data will be fetched from accumulator, another one data may be in any other register, as we have discussed in 8085 processor. Then program counter. Program counter holds the address of next instruction to be executed. Stack pointer, it holds the address of top of the stack where we are storing our temporary data. Then processor selection. Based on our requirement, you can choose a processor which can operate at higher clock speed or process more instruction per second. A processor gives high computing performance. So based on your requirement, you can choose any type of the processor. Here we have given some 4 example. One is automatic chocolate vending machine, another one is voice data acquisition system, another one is multi-port network transceivers, another one is voice processor, video processing, and mobile phone system. When you are discussing about that one, we are having some parameters: the processor speed, the processor performance, the width of the buses, program counter, and stack pointer. So based on your requirement, you have to choose whether we are in need of a fast processor, or you are in need of a slow processor, medium processing speed is enough, or you are in need of a RISC or a CISC architecture, or you are in need of a pipeline architecture or not. These all depends upon the requirement of your process. Okay, here these are all some other parameters also. So based on your requirement, you can choose that one. Next one is timing and counting devices. Timer is a device which counts the input at regular interval using the clock pulses that is generated at the input. The counter counts the events happen at regular process. Okay, that is discussed here. Next we are going for the build process of an embedded system. The build process of an embedded system in software. When you are discussing about the software, when you are writing a program, that program has to be converted into machine codes, and then machine codes has to be decoded by the processor. Okay, so before going for that processing, first if you have written a program, that will be in the high level language, that is either in C or C++ program. That program has to be converted into low level language. For that one, it has to be compiled. The compiler has to convert that higher level language program into low level language program, either by line or by the entire program. Okay, interpreter will convert the program into line by line, and the compiler convert the entire program into machine language program. So they generate the object code file. Then the object code file will be converted into linked list file. That is, what are all the necessary library files needed, that library files will be linked with that linker file, and the converted linker file will be located in a memory. That memory location will be given to the processor, and the processor will locate that memory, and then it will be executed. This is the build process of an embedded system, that is explained in that next units, next topics. So after that one, we have to discuss about that debugging techniques in the next videos. Thank you.